Welcome once again to our class this evening. We have just had a class on the determinant of a 2 by 2 matrix. But considering the size of the video, we decided to cut it and then discuss separately the determinant of a 3 by 3 matrix. So what we have now is determinant of a 3 by 3 matrix. Determinant of 3 by 3 matrix. Determinant of a 3 by 3 matrix. Okay? Like we already had said while discussing 2 by 2 matrix. When we talk about 3 by 3 matrix, we are talking about a square matrix that has 3 rows and 3 columns. So there are 3 rows here and there are 3 columns. So such a matrix is described by 3 by 3 matrix. So that if you are asked to define any 3 by 3 matrix of your choice, you can decide to define a matrix A matrix B, or a matrix C that will have 3 rows and 3 columns. So as a way of illustration, I'm going to define a matrix A. And our matrix A is going to be given this way. A matrix A is going to be defined with 3 rows and 3 columns. So I have A11, I have A12, I have A13. I have what? A21, A22, A23. And I have what? A31, A32, and A33. This is a 3 by 3 matrix. It has 3 rows and 3 columns. 1 here, of course, means row 1, column 1. 2 here means row 2, column 1. 2 here means row 2, column 2, down the line. And the concern here is, how do we find the determinant of a 3 by 3 matrix? It has a pattern, and that pattern is what I want to explain here. If you are told to find the determinant of a 2 by 2 matrix, it's actually found in connection with a 2 by 2 matrix by blinding one of the rows and the column and considering the determinant of what the remaining 2 by 2 matrix. What I mean by blinding is this. The pattern they gave us that if we want to find a 3 by 3 matrix that we should follow is this. The pattern is plus, minus, and plus. This plus should be talking about what? Column 1. This minus should be talking about what? Column 2. And then this plus should be talking about what? Column 3. Look at what we mean by that. I am here now, which is what? Column 1. Then the first entry in column 1 is A11. Then you come and write plus, which is this plus that is here. You write what? A11. You are going to blind row 1, column 1. That's what it means. Blinding them means you pretend that this row and this column doesn't exist. If this row and this column do not exist, the only thing left is this 2 by 2 matrix here. So I'm now going to get the determinant of this 2 by 2 matrix, which is this times this minus this times this. So I will quickly open a bracket. Here is my A22, so I have A what? 2, 2 multiplied by, here is what? A 3, 3. Then you say minus. Here is what? A32, so you have A3 what? 2 multiplied by, here is what? A2, 3. You are done with that, you close it. The next sign here is what? Is minus. So you now quickly put your what? Your minus. You are now talking about the second column, which is this line. Okay? The first entry in that second column is A12. So you write what? A12. You open a bracket. You are going to blind row 1 and column 2. That's what it means. Blinding row 1, you pretend as if to say this does not exist. And you pretend as if to say this does not exist. If this does not exist and this does not exist, you will be left with this entry, this and this, and this and this. And it becomes this times this minus this times this. So in that case, it's going to be A21 multiplied by what? A33 minus this and that, which is what? A31 multiplied by what? A23. You close it. The next sign is positive. You now say plus. You say what? Plus. You are now at column 3, and the first entry in that column 3 is A12. So you now, sorry, A13. You now write what? A13. You open the bracket. You are going to blind row 1 and column 3. So you are going to pretend that this row 1 does not exist and this column 3 does not exist. And therefore, what we have becomes this one. So that bracket has been opened, so it becomes this and this. So you have A what? 21 multiplied by A32 minus this and this. You have what? A31 multiplied by A22. You close up the bracket. The moment this is evaluated, you must have arrived at the determinant of a 2 by 2 matrix. So the most important thing is you remembering this pattern and knowing how to apply this pattern on that matrix. This talking about the first column, this talking about the second column, this talking about what? The third what? Column. The entries in the first column, A11, must be outside. The entry in the second column, the first one, must be outside, A11, A12, down to the third column, which is A13, must be outside. So the other one is now you obtaining the determinant of a 2 by 2 matrix, which has always been, if this and this does not exist, determinant of a 2 by 2 matrix is product of the leading diagonal minus product of the minor diagonal. Leading diagonal A22, A22 multiplied by A33 minus minor diagonal A32 multiplied by A21, A23. You close it. The same thing applies in this one. When you cancel this, okay, and cancel this, it becomes this and this and this and this. Entries of the leading diagonal 2, 1 and 3, 3. Minor diagonal 3, 1 and 2, 3, which is what we have here, down to the third one. Okay, so that's how to go about that particular problem. So permit us now to take 1 or 2 questions from Jambo and see how they used to ask questions on 3 by 3, determinant of 3 by 3 matrix for students. So permit me to clean this pattern. You already know this pattern. Okay. The first question they ask us here says, and I write. Look at what they say. They say that is number 1. They say that 3. They say 3. No, first of all, they say this. They say X. They say 1. They say 0. They say 1. They say X. They say 1. They say 0, 1, and X equals what? 0. They say find X. find x. That is the question they asked. If this equals 0, find x. Do remember that there are two ways of writing determinant. Those two ways of writing determinant is you either write, if this matrix is matrix A, you either write det A as the determinant of A, or you write something like this A, which looks like an absolute value. So by seeing this sign that looks like absolute value, you should know already that they are talking about determinant of this matrix. So the next thing you are quickly going to ask yourself is, this matrix which you have here, what is the dimension of the matrix? The dimension of the matrix is 3 by 3. 1, 2, 3. 3 rows. 1, 2, 3. 3 columns. So you are going to apply the pattern that we earlier explained. And that pattern is remembering of your plus, minus, and plus. So we come here, plus begins here. So I have plus what? X. Then I will open a bracket. We are going to blind row 1 and column 1. And when we blind row 1 and column 1, we are left with this. So it becomes this times this minus this times this. So I have x times x minus 1 times 1, 1 times 1. I will close the brackets. So I am here, I will put minus. Here am I in the second words column. The entry there is what? Is 1. I'll open the brackets. I am going to blind row 1 and column 2. And the moment I blind row 1 and column 2, I'll be left with this 1 and this 1, this 0 and this x, which becomes 1 times x here. I have 1 times x minus. I have 0 times 1. I have 0 times 1. I will close it. So here am I. I will say plus. I am at what? 0. I will now write 0 and open a bracket. I am going to blind row 1 and column 3. And the moment I blind row 1 and column 3, what I will be left is this. So it becomes 1 times 1. So I have what? 1 times what? 1 minus. 0 times x. I have 0 times what? X. Close the brackets. So I will return back here. So here is my plus x, open a bracket. X times x will give me what? X raised to power 2 minus. 1 times 1 will give me what? 1. I will now close the what? The brackets. Okay? So here we are, minus 1, open the bracket. 1 times x will give you what? X. 0 times 1 will give me minus 0. Close the bracket. Plus. 0 multiplying everything returns what? 0. So what we have here is, this x is outside, it can equally multiply this. So multiplying this will give me x raised to power 3 minus. This time this will give me what? X minus. This times minus 1 times x will give me what? Minus what? X. This minus will multiply this to change to positive. 1 times 0 will be 0. So everything is what? Really what? 0. But remember that I was told that this determinant I have done here, that it is equal to what? That it is equal to 0, which is what they gave here. So this quantity is equal to what? 0. While this one is equal to what? 0. Now, what we are going to do here is to look at this and see whether we can factorize. Because the power here is what? 3. Polynomial. Let us see whether we can bring this in down to a quadratic equation where the highest power of the unknown is what? Is 2. So there is x here, there is x here, there is x here. So I can write x, open a bracket. What should be here is x raised to power 2 minus. This becomes what? 1, of course. Then this becomes what? This minus 1, this minus what? 1. Close the bracket. This equals what? 0. And remember that any day you have something of this kind, what it means that this x could be 0, or what you have here could be 0. So if this x is 0, we already have our x is equals to what? 0. But then, or we now say or, we equally come here and we say that x raised to power 2 minus 1 is minus 2. This equals what? 0. Now bringing this thing over here, I have x raised to power 2 is equals 0 plus what? 2. So we have that x raised to power 2 is equals what? 2. And they were specific in JAM. They say find a non-negative value of x. A non-negative values of what? Of x. Such that if you want to make this x to stand alone, you take square root of both sides. And once you take square root of both sides, you have that x is equals plus minus root what? Root 2. But they were specific. They say non-negative. So we are not considering when x is minus root 2. So we are considering when x is equals what? Root what? 2. And that is exactly what the answer is in the option lettered out or detailed out in what? In a JAMB. So that is actually the value of x when you have something like this. It's just for you to know the pattern and know how to be putting them. It's not really difficult. So there are so many thousand and one other questions which people can attempt, but let us not, you already know what you're going to be doing. You understand? Let us quickly give you this one and see if you can do that one. That one says, let me call it number 2. It says if you have here to be 3, you have here to be 1, you have here to be 1, you have here to be what? 4, you have here to be x, you have here to be 0, you have here to be what? 5, minus 1, and you have here to be 1. This way. This is equals to 0. They say find x. Still, find x. And x there is equals minus 4. So you can actually solve this problem using this idea that we used here and know whether you are going to arrive at minus 4. Don't forget to subscribe to our YouTube video. Do not forget to like, share, and comment on our videos. And then get across to us if you're having challenge using the comment section. Thank you very much and keep posted for other classes.